And good afternoon, everybody. Here is a related rates problem, and it's going to be on a changing circle. So it's a word problem with a changing circle. So here is the problem. It says oil is spilling from a ruptured tanker, spreads in a circle on the surface of the ocean. The radius of the spill increases at a rate of 5 meters per minute, so 5 meters every minute. How fast is the area of the spill increasing when the radius is 11 meters? So let's go ahead and draw a picture of the situation. So we have a circle, and we have a radius. And as this circle is growing, so as the oil spill is spreading, the radius is growing at a rate of 5 meters per minute. So we know the change in the radius with respect to the change in time is 5, and that's going to be meters per minute. And what they're looking for, they want to know how fast is the area of the spill increasing. So they want to know the change in area, so they're seeking the change in area with respect to time is what they're looking for. And they want to know how fast the area is changing at the instant in time when the radius is 11. So when r has grown to be a length of 11. So to connect all these changing values, we're going to need a formula that relates everything. So we're going to relate the area with the radius. So the area of a circle. So area of a circle is pi r squared. And we're talking about how everything is changing with respect to time. So notice your denominator with respect to is going to be time. So we're going to derive this with respect to time. So we're going to derive everything with respect to time. So the derivative of 1a should be 1, and the variables disagree, so it's going to be 1 dA dt, or change in area with respect to time. And derive this. Remember, pi is a constant, so the constant pi, you can push that out to the front. Pi is like a constant, 3.14. So the 2 comes down, you're going to get 2 pi. R, drop it down to a power of 1 on the radius, so r to the first power. And then again, your variables disagreed. You are deriving r with respect to t, so it's going to be dr dt. And now we have a formula that relates the change in the area and the change in the radius with respect to time. So we can put in what we know and solve for what we're looking for. So we're solving for dA dt, that's the unknown. So dA dt is unknown. 2 pi, what's the radius length going to be? The r is going to be 11 at this instant in time. And how fast is the radius growing? So the change in r with respect to time is 5. And then we can work that out. So 2 times 5, that should get you 10. 10 times the 11, that should be 110. So it's going to be change in area with respect to time will be 110 pi. And we're talking about an area, so that's going to be meters squared per minute. So final answer, 110 pi meters squared per minute should be the final answer.